Hello, I'm Sylvain Moulera from Tevrico, and I'm here as a member of the French Ecological Engineering Professional Union. And I will present you some of the results of the BISON project, where I lead the task dedicated to the digitalization issues. The BISON project is a €3 million coordination support action granted by the H2020 program, which aims at developing the strategic research and deployment agenda to improve the mainstreaming of biodiversity in the transport infrastructure lifecycle. The project involves 44 partners and 6 third parties from 16 countries and has a duration of 30 months. The project has started last year in January, so we are about in the middle of the project today. The digitalization theme is vast and already benefits from many European strategies by its own and by sectors. So in the BISON project, we didn't aim at discussing and developing it widely, but rather focus on specificities related to future research and deployment requirements, permitting the integrated management of biodiversity and transport infrastructure in the digital environment. So to resume what we developed in this BISON's task, we try to integrate biodiversity management in the existing BIM and digital twin world, and we try to introduce the BIM concepts in the biodiversity management sector. In this respect, we use 4 main development axes to sensibilize our targets and identify the future needs of research and deployment. We initiate a common representation of what could be an inclusive BIM or digital twin for biodiversity and infrastructure to provide an expected ideal situation by 2015. We stress the synergies and mutual benefits expected with the digitalization of the two sectors. We propose pathways to integrate BIM and digital twin concepts in the biodiversity sectors and biodiversity as a theme of the BIM and digital twin users and developers. And finally, we propose some basis for future common culture. So, to develop each of the presented axes, we used a simple methodology. We conducted a non-systematic literature review completed by a stakeholder survey, which allowed us to design a first set of vision of the future on our topic and to link this vision to research and deployment needs. These preliminary results have been presented and debated in a brainstorming session with the project advisory group members, composed of international experts of our topic, not members of the BISON consortium, to feed the final vision and research proposal developed in the final task report. In this task, we mainly developed 3 main aspects of the mainstreaming of biodiversity in transport infrastructure in the digital world. First, the data and its collection, then the data management, its storage, normalization, etc. And finally, its use in the digital model. In this presentation, I will only focus on the data collection aspect, while my colleague Frédéric Géant from Aegis will develop in another talk the data management and its use. So first, we address the use of sensors to produce raw data, and more specifically what we call the mobile remote sensing. In this type of data collection, the principle is that sensors are embedded on mobile vectors of any type, such as satellites, drones, cars, animals, etc. Our work highlights that these techniques are well known in the research field in transport infrastructure management as well as biodiversity management, but it is not so used in the day-to-day life of biodiversity managers. As an example, we showed in a recent paper that up to 70% of the expert-based indicators used in the main ecological equivalence methods used to design compensation measures could be replaced by more robust and replicable ones based on mobile remote sensing techniques. In addition, the data produced for one purpose are rarely and hardly used for another one. For example, LiDAR data produced for topological use, for example, are rarely also used for tree species identification, for example. In parallel, we also pointed out the fact that to date we used to use a single type of sensor for a single usage, while coupling different sensors is expected to strongly improve the performances in detection of elements of interest. We thus questioned our current practices and identified the need for process and techniques improvements, but also tools, and particularly digital tools, contributing to solve this loss of efficiency and resources. This discussion also pointed out the opportunities offered by the development of individual autonomous vehicles, which need a lot of sensors, but will raise up new question about privacy, data sharing regulation, etc., etc. Second, we discussed the potential of static remote sensing. In this case, we mainly consider static sensors connected to each other and/or to a master element such as an infrastructure or a vehicle. Connected sensor is also known under the designation of IoT, which allows for continuous and large-scale monitoring systems. In this case, synergy seems requiring more research effort to be as useful for biodiversity management than for transport infrastructure in the context of infrastructure management. Indeed, if direct measures are often sufficient for transport infrastructure management, they almost systematically need further complex additional analysis to be used for biodiversity management. We thus highlight, for example, with this technology, some research need in the field of statistics. Indeed, to date, most models used to survey population of species are based on a discrete time basis. With the deployment of static sensors, continuous monitoring based on such technology would require adaptive analytical abilities, which are for now in the prime age. We also imagine global biodiversity monitoring systems based on the interaction of sensors networks from different infrastructure, which also raised up research questions in the field of human science, law, telecoms, etc. Third, we address the citizen-based data production issue and point out that if such data collection process is common in the biodiversity sector, it is not the case in the transport infrastructure management one. Developing this, we come to the conclusion that it will probably have few future for the infrastructure management. So synergies seems limited on this type of data collection, but must be addressed this kind of data must be addressed in the development of the future common culture and future tools. The fourth main source of data we explored are data provided by engineering models. Such models are expected to be highly realistic and used to solve engineering problems. They are commonly used in the industry and civil engineering, but most ecological models do not fit the characteristic of engineering model. So, even if most ecological models cannot be considered as engineering models, we pointed out the fact that most of them are hard to use and useful to mainstream biodiversity in transport infrastructure. And sorry, as they're hard to use in the day-to-day practice on the field, and thus we would like to improve their embedding in GIS, BIM, and digital twin tools, which would probably improve the ability of mainstreaming biodiversity in the transport infrastructure lifecycle. So here again, we pointed out major needs for future digital needs in research and deployment. Finally, we conclude our discussion in this task on data collection with the transversal topic of artificial intelligence. We show that AI will soon be the first treatment on the raw data and constitute a major process for building secondary data exhibiting high added value. But I won't develop more this section because research and deployment needs on this topic are, for most of them, not specific to the integration of biodiversity in transport infrastructure management. So we discuss it in the report, but I won't develop it too much this point here because it's part of the EU digital strategy and so on. So to close this part of the discussion, I suggest you to follow Frédéric's talk to have the rest of the story. What will we do with this data, or to go in deeper details by reading the report available soon on the BISON project website. Thanks for listening.